Energy difference for ethane is around 10 kilojoules or something like that, 11. This is a pretty small amount of energy. So room temp is enough for that to happen. Okay, let's do a same kind of process, but something that is a little bit more fun. Let's make butane. Please go ahead. Tag 2 more carbons to your ethane. Let's make a butane molecule. And
all right, thanks, Gemma.
Can they be a different color?
so let's make a butane molecule. Butane. How many carbons in butane, guys?
4.
Let's go ahead and make it. So
What
just
color?
put 2 more.
I think butane is 4.
Okay. Just cause I will ask you once you. Where's my pen? Where do I keep putting my pen?
Oh.
Just so that we all start at the same place. You don't have to, but just bringing us all on the same spot. Please make looking at C2C3 bond. So remember, in Newman projection, we can only analyze one bond at a time. So looking along the carbon 2, carbon 3 bond in butane, I want you to make your model align with this Newman projection. Give me a second. You know what? Why? Okay, fine.
Did you do yours like that?
Yeah.
Wait, what did she say?
You can move it.
We need to do it like that.
Is that eclipse or staggered?
Eclipsed.
Okay, so and eclipse, see, in ethane it didn't matter because they were all hydrogens. Here it matters because 2 of those are methyls and then the other is a hydrogen. So make an eclipse conformer where the methyls are eclipsing each other. The dihedral angle between the methyls is 0 degrees. Does that sound okay, everybody?
Yes.
Yes? Everyone has that? Cool. Let's make it.
Okay.
Out.
Now go ahead, let's do the rotation. This time, we will keep the back fixed, move the front carbon only. So and again, 60 degrees. So I'm going to not change the back carbon.
Okay.
So that was.
Is that the rule again? Please
This is
remember,
the
none of these are rules. I'm just trying
is the
for us to do the same thing. But you could, that's a choice. Which one do you want to move or not? Let's rotate the front carbon. Does it have to be clockwise or anti-clockwise?
It's your choice.
Doesn't matter. Why don't we this time do anti-clockwise? Again, just for variety. So the front carbon, I'm moving anti-clockwise. So eclipsed becomes what? Staggered. Now, where would the methyl be? Once you moved it anti-clockwise, where would the methyl be?
On the right.
Left. I went anti. If you went clockwise, it would be on the right, right? And that's totally fine. But do you agree? And what's here?
Hydrogen.
And
Hydrogen.
does everybody have that structure?
Yeah.
And make sure it's matching your model. Because you need to be looking at it along the bond, Mar. That's the important part. You can't look. So your eye has to match that level. Okay?
This level down here?
This C2, C3.
Okay.
Carbon 1, carbon 2, carbon 3, carbon 4. So we are looking at carbon 2 and 3.
Okay, so when you move it,
So let's keep
To the
this
left.
fixed. Move this 60 degrees.
oh, the front?
Yeah.
For me, the front.
Yeah, for you. For you, the front. Yeah. Got it?
Okay.
Does it match that drawing? Okay, guys, go ahead. Another 60 degree. We are not moving the back. We are only moving the front. So starting with what we had before, what does it become? Staggered becomes eclipsed. Which means we have a bond that's eclipsing. I don't have
Okay,
space.
I'm not.
Right there, right here, and right there. right? Oh, sorry, wrong. What did I do? It needs to come to the front atom because that's your front carbon, right? Everybody? What's on this bond?
CH3.
What's on that bond?
Hydrogen.
And
Hydrogen H.
do you all have that? Does your structure look like that? Go in the same direction. Don't change your direction. We are going anti-clockwise, so we are still going anti-clockwise. Keep going. Okay, I think you know what I'm going to ask you to do. Another one. 60 degrees, going anti-clockwise, not moving the front, only moving the front, not moving the back this time, right? So only moving the front. Back is fixed. So eclipse will become what?
Staggered.
And this time staggered.
The front.
What's on this bond?
CH3,
What's on the other one?
hydrogen.
And okay, next one. Eclipse will be staggered will become what?
Eclipse.
So that's again, I'm choosing to hold back fixed. I'm choosing to only move the front carbon. So becomes eclipsed again. What's on that bond? What's on this bond?
CH3.
And H and H, right? And then how many have we done? 1, 2, are we back to square one? Not yet. Not yet. Okay, let's get to one more. Not moving the back, just moving the front. So it becomes staggered again. Staggered. What's on this bond?
CH3.
And H and H. And if you do one more, you go back to the front. Am I right?
Yeah.
Everybody okay?
Yeah, okay.
Okay.
Finally got it.
I'm going to just number them as 1 and 2 and 3 and 4 because otherwise it'll be hard to refer to them. How many eclipsed in this whole cycle? How many eclipses do you see in this whole cycle?
3.
3. How many staggards do you see?
3.
3. Because eclipse and staggards alternate,
Yeah.
right? Okay. Please tell me, if you look at eclipse number 1, eclipse number 3, and eclipse number 5, are they equally stable? Are 1 and 3 and 5 the same? No, they're not. If you're only comparing 1 and 3 and 5, which of these 3 are the same? 1, 3 and 5 structures. Which of these 3 do you think are actually the same as each other? 3 and 5. Why are 3 and 5 the same?
Because the
Exactly.
C doesn't line up.
You have CH3H eclipsing, same there. H and H eclipsing, same there. Another CH3H eclipsing, right? Same. What about 1? How do you expect 1 energy to be in relation to 3 and 5?
Higher.
Do you all agree? Because it's less stable. Why is 1 less stable than 3 and 5? The bulkier the groups, the bigger the groups or atoms, their electron cloud is also bigger. So if you're taking bigger things, bigger atoms, bigger groups and pushing them closer to each other, is that going to be a happy situation or a bad situation?
Bad situation.
The electron cloud of methyls are bumping into each other. Is that better than methyl and hydrogen bumping into each other or worse?
Worse.
That is your least stable eclipse because the dihedral angle between the biggest groups is the smallest. It's the biggest groups that decide because it's the biggest groups that need more space. Is everybody following that? Okay, let's look at staggards. How many staggards are there?
3.
2 and 4 and 6. Am I right?
Yeah.
Yeah.
Which of those staggards are the same?
4 and 6.
4 and 6 are the same, are you sure?
I think 2 and 4 are the same.
2 and 4 are the same.
Oh.
2 and 4 are the same?
No.
No.
They're all the 6 are the same. 2 and 6 are the same.
Wait.
No,
So we have 6.
They are.
Six.
2 of them are the same.
maybe 2
Again,
and 6.
my suggestion will be pick the biggest things. I mean, what do we have here? We have metals, hydrogens, hydrogens, hydrogens. Don't we have the same here? Metals, hydrogen, hydrogen, hydrogen.
Yes.
2 and 6 are identical. There is no difference in the energy of 2 and 6. Do you all see that? Everybody? What about 4? In relation to 2 and 6.
The methyls are opposite each
So,
other.
in terms of energy,
Has less energy.
absolutely. Why? Because look, the biggest things are right opposite each other. What's the dihedral angle between this bond and this bond?
180 degrees.
Right? What's the dihedral angle between this bond and that bond?
60 degrees.
60 degrees. The farther away the groups are, the better the things is. So absolutely, 4 is way more stable, lower energy compared to 2 and 6. Does everybody see that?
Yeah.
So how do we represent that as a graph? Because it's conformation analysis is all about graphs. So unlike ethane, where there was only 1 eclipse and 1 staggered, here we have 3 eclipses and 3 staggards. So we have to represent that appropriately. Ready? Starting with structure 1. Is that eclipse staggered? Structure 1, guys. Eclipse
Eclipse.
staggered. So it should
Eclipse.
be high energy, low energy.
Start at high
High.
energy.
Then we go structure number 2. Has it become eclipse or staggered?
Staggered.
So does the energy go down or up?
Down.
Number 3. What do we have?
Stag.
Eclipse or
Pardon,
staggered?
Eclipse.
Eclipse. So does the energy go
Up.
up or down?
Up.
Up. But here's where you got to pause.
Oh.
Does it go as high as that? Why?
What?
Because 1 is louder. 1 is compared to 3. Compare 1 and 3, which is more stable.
1.
No,
Three.
3. One has more
Higher energy.
Yeah.
Right? So when you come to 3, energy goes up, but does it go as much as this? No, it goes little bit lower. Agreed? Everybody okay? Now it comes to 4. What happens to the energy? Goes up or down?
Down.
As down as that?
Yes.
Or even lower. 4 is way more stable than 2 because it's 180 degrees dihedral angle. Agreed?
Yeah.
Then come next structure. What is that? Where am I? 5. Structure 5.
It's eclipse and it is
Lower.
Structure 5.
Yeah, same as 3.
It's high but same.
Same as what?
Oh, because
same
it's
as 3.
Same as 3. Am I right? Is that correct?
I think so.
Because it goes, they're equal energy. And then from there, where do we go from there? From 5 back to 6, where do I go? Same as
same.
2. And of course, if we were to go further, one more structure, any predictions, what would 360 degrees be? Same as 1.
Yeah.
And it just goes back to the original. Everybody okay?
Yeah.
Is everybody agreeing that this is structure 1, this is structure 2, this is 3, 4, 5, 6, and that will go back to 1. Am I right? So, what does the graph look like? For butane, that's what it looks like. Again, what we're looking at is each 60-degree rotation, you analyze the Newman projection and decide, okay, is it eclipsed or is it staggered? And based on that relative energies, you can plot a graph. One thing very important, eclipses are always on the peaks. Always. Staggards are always in the valleys. Always. Sounds okay, everybody? Questions? Okay, next thing. Look, using the same example that's here. is Eclipse, oh shoot, I deleted, why did I do that? Eclipse, no, sorry, hold on. Staggered 2 and staggered 4, are they the same? Is 2 the same as 4?
No.
No.
This staggered, where the dihedral angle between the biggest groups is 180 degrees, is called the anti-staggered. Anti basically means opposite. That's the anti-staggered conformer. The other two that are staggered but not anti, because the dihedral angle is 60 degrees there, approximately, are called Gauche Staggard. So of course, that's also a Gauche. Okay? So there's anti-staggered when the biggest groups are 180 degrees away from each other. Gauche staggered when those are 60 degrees away from each other. The eclipses don't really have a special name, they're all eclipsed. However, this one where the dihedral angle is 0 degrees, I call it a Syn eclipse. Syn meaning basically right next to each other, the same side. So those are also some terms. Staggered, eclipse. Staggered is way more stable than eclipse, but then even in staggered, anti-staggered is the most stable compared to Gauche staggards, and then of course Syn eclipse is the least stable of all. Everybody okay?
Yeah.
Cool. So, can you please pass these?